Okay, hi grade nines. So here is method two. You have a question. It's got lots of fractions, variables on both sides, constants on both sides, and what's an efficient way of tackling this problem? Well, what I found by grade nine, most grade nines, or at least a lot of grade nines, they're pretty comfortable with what I call the basic fractions, like quarters, thirds, halves, fifths. So you may just want to just go straight to decimals, okay? I call this the straight to decimal method, but you don't have to worry about naming all your strategies, okay? In other words, just look at it and get a feel for, you know what, Mr. Smith, I think I'm okay dealing with all of these in terms of fractions. Like for instance, 1 1/4, that would be 1.25 m, okay? Now you're gonna have to ask for a separate video or ask me in class if you want me to go over the basics of converting decimals to fractions or fractions to decimals, but there's also plenty of YouTube videos. So I'm just rewriting this question. Now 7 divided by 4, that is the same as, this is where a mixed number may come in handy. 7 over 4 is 1 3/4. Well, I know what 3/4 is. It's 0.75. So this is 1.75 m, again, minus 0.5. Okay? Now it's going to be very similar to the last problem. You need to get your variable terms together. So here are your variable terms. Okay, right there. You got your m's, you got your constants, and away you go. Okay? So I'm going to start, this is a positive. You don't see a sign, you assume it's a positive. So there, I'm going to zero pair this out by subtracting 1.75 m. That will get rid of the variable on that side. You must always maintain balance in your equations. So whatever you do to one side, you do to the other. You noticed I lined up the variable term. You don't put the minus 1.75 below this. This is a constant, right? There's no variable attached to it. It's not appropriate to try and get these two to talk to each other. Okay, so what is 1.25 minus 1.75? This might be starting to look a little familiar to the last video. It's just all I did is convert to decimals earlier in the equation. I didn't touch this term. I left it alone. I didn't do anything with it, so you rewrite it. I didn't do anything with this either, so I left it alone. Okay? So now what am I going to do? Well, I'm trying to get all my variables together. I did that, right? Two of these parts of the equation, right? Remember we talked about there's 4 parts. Two of them have now simplified to 1. Now I'm going to deal with the constant. So why don't I subtract both sides with negative 0.5? Okay, that will zero pair this out. That's a good thing, because algebra is always the process of simplifying equations, right? That's the goal. 4 parts. Now I've got what I call a one-step equation. Negative 0.5, subtract 0.5, that's a negative 1. Divide both sides by a negative 0.5. Divide both sides by a negative, don't forget the negative, Mr. Smith, the negative 0.5. That, the reason I divided, because this relationship between coefficient and variable is multiply. So the opposite of multiplying is division. We show division by using the fraction lines. Fractions is division. So we divide both sides by a negative 0.5. This gives me a lovely positive 1m, but we don't write positive 1s in algebra. We just content to write m by itself. It's isolated, okay? This was the goal, to isolate the variable, to get the variable by itself, right? Isolate means by itself. Negative 1 divided by negative 0.5, that's equal to a positive 2. Guess what? That exactly matches our answer from the last video, from method 1. So there's lots of ways to do this. There's yet a third method that I'll post later this week, but for now, I'm going to post method 1, method 2, where I convert to decimals right away, and you still get the same answer. No matter what method you choose, you should get the same answer no matter what approach you have. So if you and a friend have 2 completely different ways of solving a problem, that's not a problem at all. But you should have the same answer at the end, okay? All right. Talk to you later, guys.